What are we going to talk about today before we introduce ourselves? Talk about, DLP in general. Talk about what we looked at. Just so you know that this is not a which vendor is better talk. Like, we're not endorsing any particular vendor. It's really more about bugs in security products kind of thing, so that you can make informed decisions about the things that you buy. We'll talk a little bit about what we did to these various products. We'll talk about our findings in each of them, and then we will conclude with a question and answer, probably like the last 10 minutes of the talk. So, who are we, and why should you listen or not listen to us? So I'm Zach Lanier. I am a director of research at a company called Silence. We're like an anti-malware endpoint security company. I'm old hat. I've been around for a bit, but most people don't know me, that's cool. So I've done a lot of mobile security research, embedded security research, old pen testing guy, and co-author of the Android Hackers Handbook. Just a shameless plug. And my co-presenter.
Hi, I'm Kelly Lum. I'm a security engineer at Tumblr. My background is not just all startup. I started out in government, went into finance, and then finally made my way into the Tumblr world, where you can, if you're not familiar with Tumblr, it's where you can get some of those really awesome animated GIFs that you find in our presentation. There's a bird. I don't know.
Yeah, and this morning when trying to edit a few slides, I said, Kelly, what's your second bullet point that you want to describe you? And she just went, there's a bird. A bird. So we just left that in there.
I'm also a adjunct professor of application security at NYU Poly, which is in Brooklyn. For any of you not familiar, we have online courses, so, just a shameless plug there.
So why did we choose to look at data loss prevention? Well, why is data loss prevention a thing to begin with?
Right. So let's see. I'm trying to think around how long ago, but at least 10 years ago, people started realizing that there was such a thing as security breaches that were a big deal. We in the security industry have known this for a long time, but large organizations were just starting to realize that maybe having my information get ferreted out of my company is not a good thing, and I'd like to prevent that from happening. And so how do you prevent doing that? Well, you could do one thing, which is have a good secure infrastructure just holistically across your entire organization, or you could find the ubiquitous or the mythical silver bullet that you can plop into your network that'll solve all of your data loss or data leakage problems. DLP is usually, we will get a little bit into the kind of concept of bypasses and why we didn't really focus on them so much, but really DLP has kind of been touted as something that will keep honest people honest. It'll keep somebody who's doing data entry from accidentally copying and pasting sensitive information like social security numbers or credit card numbers into an email. Maybe prevent one of your developers from sharing source code with people outside the organization, like look at this cool function I wrote, put it on, GitHub or something so that other people can use it if you don't want them to do that. And, also maybe prevent or maybe help people to kind of know when data breaches occur. So, your database gets dumped and it's being snuck out of your organization. The whole files falling out of the back of the truck kind of situation there.
So why did we choose to look at DLP? Well, one of the points that's not on here is this was actually initially Kelly's idea some time ago, and a couple years ago we started kind of digging into this a little bit more because she was like, hey, we should look at DLP. We were really curious about the attack surface that's introduced by DLP products, much like if you've ever seen, we've seen stories about antivirus software and management interfaces around that being actually, increasing attack surface, having privilege escalation vulnerabilities inside of, antivirus agents and endpoint security agents and things like that, as well as the reliability of DLP. Like we kind of alluded to, bypasses are that's cool, but anyone can bypass DLP. That's pretty easy peasy. But how robust are these security products? like I kind of mentioned just a second ago, these DLP agents that reside on the endpoint or that crawl a database or that are an appliance, they're oftentimes highly privileged or have a very, very advantageous position to monitor the network, monitor traffic, to interact with databases, interact with email servers, things of that nature. So if they do get compromised, suffice to say, that's really good for me as the attacker, right? I mean, now I have... If I can compromise your IDS or your DLP appliance, then I can watch all the things that can watch. Testing the security of security products is a huge, very, very, very interesting thing for the both of us. I'm sure some of you probably feel the same way.
We both have spent time in Brooklyn, and we love irony, I guess.
Right. And oftentimes, big vendors will buy smaller vendors, integrate them into their portfolio, their product offerings, and then they just kind of shelf them. They put them out to pasture, and they just sort of rot there. So updates and security fixes and things like that don't really happen. So we would be remiss not to mention some other people who've done this type of research before. Securosis, an analyst firm. That has done a lot of research into DLP from the deployment side, really more of the other kind of Bakeoff, like how to properly do this, how to properly select a DLP vendor, and how to correctly use them in your enterprise. Defeating DLP by Matasano, excellent presentation at Black Hat USA many years ago. If you haven't seen that and you're kind of in the DLP market for some reason, I would strongly recommend it. There's another presentation at DEF CON a while back about using OpenDLP, an open source DLP product, for more of an offensive attack scenario, like using OpenDLP to actually steal data. And there have been many others, so too many to list. And of course, we've done this a couple times now. So, just to kind of summarize the general architecture of most DLP products, and this is probably not an unfamiliar diagram to anyone who's ever used a computer on a network before. But typically, there's some sort of management server. There might be a network monitoring appliance, like we mentioned. An endpoint agent. There might be an agent that sits on the mail server itself. Something that integrates with Exchange or with Domino or what have you. There might be an agent that sits on a database server or crawls, interacts with the database to look for sensitive data or if data is not encrypted or what have you. Some of them might also actually reside on your web filter. So, if you have a proxy at the perimeter that, proxies all web traffic and filters that, some DLP products will integrate with that. And of course, they send push policies and configurations down to these various devices, and alerts are typically sent back up to the management server where you get your cool little crystal reports. To kind of dig down a little bit further into how most DLP products are actually structured on the device itself. So some sort of policy database, they're for an endpoint such as like a Windows machine or a Linux machine or an OS X machine where the agent is, there's typically, most of them have some sort of clipboard monitor, a way to hook into the clipboard to make sure you're not copying and pasting, a credit card number or some sort of personally identifiable information. Oftentimes they'll have a removable device monitor, so a thing that makes sure that you're not putting that sensitive file onto a USB thumb drive. And then most of them go into document and file specific sort of parsing, right? So that could be real time, that could be from something that crawls the file system, and then those typically have some sort of format specific parser, some markup language, Office document, just plain text, what have you. The ones that also do actually look at network traffic, Obviously, they'll typically install some sort of network driver, have some sort of way to monitor the interface, and then maybe, where possible, actually analyze and parse specific protocols. So HTTP, making sure that you're not downloading or uploading something that has PII or some sort of sensitive data. They might have local to the endpoint some sort of like an SMTP or mail monitoring. Some of them will parse Skype messages, things like that. And whatever the result of that sort of that process is, typically goes down into some sort of abstract inspection engine, something that actually applies all the rules based on some policy that the administrator set. And then enforcement decisions might be made. Don't allow me to copy that thing. Don't allow me to upload that file. And the results of that will typically go into some reporting engine somewhere, either locally or on the management server. So an example of a workflow.
Right. So the previous
typical
slide was kind of how it works under the hood, and this is sort of showing how the user or the administrator would interface with this product. Apologize that it's a little hard to see, but we'll go through it. So at the top, you're going to define your data identifiers. Basically, tell the system what you want to look for. Some organizations, you may be worried about credit card numbers, social security numbers. Some organizations, you may be worried about source code. You may be worried about maybe certain metadata, words like classified, top secret. And you're going to also select file attributes. So are you looking at Word documents? Are you looking at .php files? Are you looking in sort of the metadata of images like the EXIF data or whatnot? Once you create your data identifiers, then you can create a template where you take those identifiers. Maybe you want to kind of put them into different categories. And so you can apply a subset of those data identifiers to a particular policy. When you create the policy, you're going to identify your target. Are you going to be looking at this on your, if you go to the previous example where we said you can look at mail servers, you can look at web servers, you can look at people's laptops, desktops. So say, where do you want this policy to be enforced? What particular devices? And what channels? Do you want to monitor certain network traffic? Maybe you are concerned more about HTTP, FTP. Maybe you're concerned more about IMAP, POP. And then select the template that you've designated before, what you want to apply to those targets, to those channels. And then what's the action you want to do? You can either log it, let it go through. Maybe you want to block it. And how would you want to block it? Do you want to block it silently so the user doesn't know, or the person committing the action doesn't know that it's been blocked and just thinks something failed? Do you want to pop up a message, say, ticks, don't do that? It really depends on what your sort of end game is. Then you're going to, click the magic button that deploys the policy to the endpoints where you want it to live, and then monitoring that policy will start to run, and monitoring will take place, either in some sort of logging system, syslog, Splunk, whatever, and then also a method for reporting.
So this is a pretty standard workflow, despite the fact that it specifically says Trend Micro. So if you work for Trend Micro, we're not calling you like lame or anything.
Yeah, but this is not an endorsement nor an indictment of Trend Micro.
Right. And one other note here, the reason that we kind of go through this as dry as it seems, this part, is these are all the areas, each step in the workflow from more of an offensive standpoint are exactly the things that we're thinking of. Okay, well, how are they parsing configuration? How are they doing deployments? How is their regular expression matching for files that they're looking at, things like that? How are they logging?
Right, so you can actually look at each point on this little flow chart as a particular place where security could have a breakdown.
So what did we look at? And this is, I didn't have time to remove this. No one's going to get the joke. It's a Saturday Night Live thing in the U.S., but it's Target Lady. It's a store in the U.S. and other places probably. So our first round, this was like when we first started doing this research. So some of these and the results that are herein for these products is a little older, but you'll kind of get the idea. So we looked at Trend Micro, their DLP management appliance, their endpoint agent. We looked at Sophos from a few different angles. They have a unified threat management appliance. We looked at their console and their endpoint agent, which is actually really just their antivirus software. For WebSense, they also have a centralized management server referred to as Triton. They're now called ForcePoint. So, this is, you can tell how this is, a year or so old. Their endpoint agent, their appliance, their protector appliance, which actually is a virtual appliance that runs Linux, as most of them do. And then for good measure, good old open source project called OpenDLP. So to kind of break these down into their constituent parts.
Okay, so first we'll go through Trend Micro, which we have already seen a little bit of a taste of. So Trend Micro is primarily Windows. We have our Windows endpoint agent, which is going to do your monitoring and your policy enforcement. The interesting thing about Trend Micro, the agent, is it actually acts. Its behavior is similar to rootkits in that you install it and it kind of hides itself. I guess the justification there, not that I can read the minds of people at Trend Micro, is that, if somebody is actively trying to disable the DLP, it would make it more difficult for them to do, but it's also a little bit concerning because if there is an issue with the agent, that's going to make it a lot harder to observe. There's also Network Agent. It's a virtual appliance, and you use that, obviously, to monitor network traffic. And there's also a crawler. It's a remote crawler, and that's for digital assets for machines that are not on the corporate network. The management server is another virtual appliance. It's Linux-based, and so the management server is going to talk to all of these components that are listed before, deploy policies, set up configurations, actions, and logging.
So WebSense, their management server is called Triton, like we mentioned. It actually uses Microsoft SQL Server, so that's its database backend, but you need a dedicated Windows machine to run it, and it actually runs Coyote, so Apache Coyote. So they're using all sorts of fun Java things, which never goes wrong. Like kind of mentioned in the chart earlier, it's pretty typical. They all have Windows, OS 10, and Linux endpoint agents. Additionally, so pretty much for every one of these, and we're gonna mention this multiple times, all of the endpoint agents, especially for Windows, will install some sort of file, file and network drivers. They'll hook clipboard, etc. Their protector appliance, their network monitoring appliance, is virtual appliance based on Linux. It has a restricted admin shell. No, we did not break out of it. We ran out of time. Much like Trend Micro, they also have a crawler agent which can talk to databases, can talk to remote file systems, etc., to kind of in the background look for documents with sensitive data in them. Sophos, their enterprise console, Kelly did more on their
right.
side.
So one of the things that we kind of seen as a common trend, and this is one of the things that kind of set Sophos apart, is the management console is basically a bundled Windows operating system with the management software living inside of it. So you're actually getting a copy of Windows that you're...
That's the other one. That's the bad one we don't talk about.
Oh. The enterprise management console, primarily .NET, and we'll get into a little bit of what problems arose from their usage of .NET. The endpoint security is sort of a bundled solution where you get all of your little security top hits, antivirus and DLP and firewalling kind of functionality. Those are available for Windows, OS X, and Linux.
So pretty standard. OpenDLP. You can download it as a virtual appliance, or you can install it. I wouldn't do that at all, ever. Don't even run the virtual appliance. Spoiler alert. It's Apache with a lot of Perl. I don't care for Perl. I know someone gave a Perl talk that was probably really good, but I don't like Perl. And then they have their own. They have a Windows agent, and they also have a Perl-compatible regular expressions or PCRE-based document parser. And they also have a file system crawler. It can actually use SSHFS to connect to non-Windows machines to crawl all your documents. And for some reason, there are Metasploit modules that are not like actual exploitation modules. They're like to use OpenDLP in some way. I don't know why, but that exists. So one thing in the first four, a couple of them that we noticed, there's this thing called key view. Is anyone familiar with key view? Raise your hand if you're familiar with key view. You don't have to admit it. Okay. Well, there's this key view is it's by HP Autonomy, their autonomy division. They had purchased it some time ago, and it showed up a lot. So this key view OOP or KVOOP binary, it kept showing up, and it's used from what we gathered based on our analysis. It's used to basically take a bunch of different document formats, disparate formats like Word, markup languages, binary formats, etc., and sort of normalize them and filter them down into sort of a standard abstract representation so that other filter rules can be applied. And this is not just unique to DLP. It's used in big data analytics platforms. It's used in messaging servers, so like Lotus Domino uses it. So what was interesting about this was just, here's like an example. This EP classifier in WebSense spawned like a ton of these KVOOP processes. So this was like on the Windows endpoint for WebSense, kept spawning those. And then on their appliance, I know it's very hard to read, I'm sorry, but this like policy engine process would then spawn a bunch of these KVOOP processes. So if you were interested in finding bugs, that would be the place to look. Like if you were like super duper interested in finding a bug that affected a variety of platforms, that's your homework. Go do it. Just saying, we don't have any. Sorry. So now on to the second round of targets. For legal reasons and PR reasons, and if my PR people are watching this, I'm very sorry. We had to change the names of the second round of vendors. So that's really all I'll say. So the second round of vendors, and this is before we get into the findings. So we called them Alpha, Bravo, Charlie, and Dingus. So just so you know, we're going to refer to them as such. Alpha, for instance, also had a Linux-based virtual appliance, Windows-based endpoint agent. Bravo, very similar. Theirs was a Windows management server that you had to install on your Windows host. OS 10 and Windows endpoint agents. Charlie, again, very similar, Linux management appliance, Windows, Linux, and OS 10 endpoint agents. And then finally, our favorite hypothetical company called Dingus. They had a console virtual appliance. They had their network virtual appliance and a Windows-based endpoint agent. So to kind of break those down, start with Alpha.
Okay, Alpha DLP. Alpha DLP was extremely interesting to me. It was, if anyone's familiar, most people are probably familiar with the Mary Shelley book, Frankenstein. It was sort of a Frankenstein's monster of a lot of technologies that, not to sound overly negative, but things that, in general, the trends I see that information security people tend to hate on. So what are some things that I don't like? I hate it when somebody takes, or a company takes an open source product and then acquires it and then closes off the source. I like open source. I like the transparency of it. So this kind of sticks in my craw. Their admin panel, entirely written in Flash. We've never had security problems with Flash, but I'm looking in my crystal ball, and I'm sure that we're going to find some in the future. The Windows agent, a smaller but also equally kind of disturbing Frankenstein of, I guess they just kind of picked a handful of languages and threw them against the wall to see what fit, because there's a lot of different components, which is, good, modular code is good, but it's a combination of .NET, Java, and Erlang. Java and .NET are sort of like, I don't know, that people have seen like the Batman versus Superman movie. I heard it wasn't very good, but .NET and Java kind of remind me Batman versus Superman. They also use the Adobe technology action message format. So going back to their little Flash fandom, they're using that for their communications. Also, just a very interesting choice. And we'll get into what some of this what problems turned up because of this.
So Bravo DLP, this was kind of different than most of the others. So this actually kind of set Bravo apart. They actually used an MMC, so Windows Management, Microsoft Management Console, snap-in. So explain why that's significant when we get into some of the findings. But uses Microsoft SQL Server for the backend. So again, you have to install it on a existing Windows machine, dedicated database if you want, whatever. They also had a separate service that was their content monitoring service. So that was like their crawler. It would go out and kind of look for documents. It's their crawler basically. Windows Endpoint Agent installed a ton of drivers. So all sorts of network drivers, NDIS and TDI. File system drivers. So a lot of if you haven't picked up on this, a lot of the operations related to monitoring files, very similar to like antivirus, right? And sort of, clipboard hooks, things like that. Their endpoint agent, it was similar to the Windows agent, but not feature parity. They didn't really do all of the network monitoring stuff, and the clipboard operations were sort of slipshod. It uses a lot of open source and free libraries, especially on the OS X agent, which is funny. For example, Boost, if you're familiar at all with like C++ development, I'm sorry. But also FreeDCE, which is a DC RPC library, so that the OS X endpoint agent can do Windows communication thingies, RPC communications. Charlie DLP, yet another virtual appliance for Linux. Windows endpoint agent, same exact thing as all the others. Clipboard monitor, file monitor. Had a particular affinity for monitoring URLs that were being opened in various browsers. The endpoint, they also have a Linux agent for Ubuntu/Debian, so had to be for one of those distributions. They had this really janky notification tray for whether the agent was working, but it didn't really do anything. So I don't know. It's kind of like a second-class citizen for them. We didn't really look at their OS X endpoint agent, but they also did a bunch of MDM, like mobile device management and BYOD type stuff. We didn't really look at that, but that's a feature. And then finally, Dingus.
This is something that came to us in a fever dream one night.
Yeah, this is totally a hypothetical company that doesn't actually exist for legal reasons. It's another virtual appliance. Theirs is actually CentOS-based, so that you'll understand the significance of that later. Network appliance as well, also CentOS-based, has options to do inline, it can sit off of a SPAN port, or it can proxy using Squid, good old Squid. Their endpoint agent, same, the usual exact same thing as everyone else. So what did we do before to find? I know everyone's looking for the juicy bits, but we have to talk about science first. So our methodology, we applied a lot of the same rules to different to the appliances and stuff. Looked at how they parse documents that are traversing the network. Look at how they're parsing their local. How do they parse configuration files? What format are they using? How are configs and updates being deployed? Are they signing configuration updates? Are they signing packages that are being applied to the appliance, etc.? From the operating system level, how do they harden the appliance? Does it come out of the gate sort of locked down? Are exploit mitigation, baseline exploit mitigations turned on? Did they go above and beyond that? For the endpoints, kind of same thing for parsing. Trying to, file fuzzing is obviously a big thing there. but it's very very taxing and takes a lot of time if you want to do it right, which I don't. Again, update and deployment mechanisms. How are they getting their updates, configuration updates for their drivers, especially on the Windows side? Actually, doing things like ioctl fuzzing, because if we can, drivers exist in a very interesting place in the kernel that would be good to have a foothold on a working exploit. How do they also do network protocol parsing? Can we do just like basic protocol fuzzing and get things to crash? We can. For the management server, and also for the network appliance as well, for the ones that had this option, looking at how the web server or the web application is configured, like OWASP top 10 type stuff. You'll be surprised soon, or not. I don't know. Database, if the management server had a database package with it, if it was a virtual appliance, did they lock that down correctly? Are they actually allowing remote connections? How are they storing sensitive data? And then, of course, again, the operating system, if it's a virtual appliance, kind of applying the same sort of routine there. Excuse me. Okay, this is what you wanted.
Okay. Just before we get into it, these have been reported to the vendor, and as far as we know, there are no ODA in this presentation. So apologies, but still, stuff.
Correct.
All right. So in terms of general observations, we noticed that on the Linux appliances, it really kind of was baseline install. They didn't. Most of the examples we've seen didn't really go out of their way to kind of harden things, in terms of not using default, passwords on things or blank passwords, not segmenting things into users and groups with lockdown privileges. So many of the services were running as root. We didn't see any sort of extra exploit mitigation, but beyond what the operating system did by default. So, turning on things like ASLR. There was also the endpoint agent software. Remember, we said before is that these things are very advantageous, and they have to be just so that they can give you the functionality that you expect out of the product. But one of the things that we noticed is that the endpoint agent software was also running with very, very high privileges, either as root or local system, rather than running maybe as the privilege of the logged in user or running as its own user that has privilege to do whatever it needs to do. Monitor network traffic, okay. Look at files on the file system. You probably, if you want an endpoint agent that's on, let's say, a user's box, like a laptop or a desktop, probably don't do your network monitoring there. And just general abuse of security best practices, the things that we learned, when we went to school or when we bought a book. Encrypt your communications, people. Go through the OWASP top 10, understand what it is, and train your developers to code defensively against it. We also saw the occasional bug inheritance. We did talk about how a lot of these products, use open source libraries or use commonly available libraries, the ubiquity of KeyVoop. So we did occasionally see bug inheritance from the dependencies that they had. So using outdated Java runtime environments, free DCE, so etc. Again, we've never had any problems in Java. We've never had any problems in Flash, but looking at my crystal ball, I'm pretty sure we're going to have some in the future. Okay, so we'll start out with Trend Micro, since that's the first one that I looked at. And again, I said Web Security 101. You can see these are all independent instances of both reflected and stored cross-site scripting that we found in the site. Some of these were so easy to find that Burp found them automatically. That's not good, especially when you're spending money on a product. I would expect better than this. The same goes for cross-site request forgery. Again, you're a security company. You should know what cross-site request forgery is and how to code defensively against it. Why is this a big, these seems like silly bugs, but why is this a big deal? Well, because the management software and the agents have access to a lot of data. And if you can force the person logged in as the admin to perform an action such as, hey, if you see a file with sensitive information, instead of logging it, why don't you just delete it? That's not good. We also noticed with the crawler that they had to basically kind of go around and look for things that were bad, the communication was in plain text, so you would have some sensitive information leakage there. So again, I don't know why this happened. These things were fixed, but it could just be a side effect of maybe the company buying a smaller company and not really knowing what they bought and not really kind of going through with a fine-tooth comb. We don't know. But just a general takeaway, you spend money on a security product, that does not mean that that product in and of itself is secure.
So for Sophos, it's going to be really disappointing, and I'm going to talk just long enough for that GIF to play, because it's really funny. Nothing. We didn't really find anything. That's not to say Sophos doesn't have other areas of interest. There have been a lot of bugs published for in some of their software. A lot of it is in .NET. I guess, Kelly, if you want to talk about the .NETs, like what they did right.
Okay, so one of the advantages of using the core libraries is that they had the built-in security that was implemented in those core privacies. So best practices, like using parameterized queries rather than string concatenation for your SQL, contextualizing your input and output as a preventative measure against cross-site scripting, and also using the standardized encryption libraries rather than rolling their own.
So kind of blazing through this one a little bit. So on their appliance, their Astaro appliance, they actually did some decent things in terms of chrooting. Not that chroots aren't defeatable, but dropping privileges for services that were running on there. The web app was pretty clean. Weren't really any major issues there. And by default, they really locked down login and access restrictions. So you couldn't just throw the appliance onto the network and have someone immediately logging into it and owning it. For OpenDLP, again, open source product. The one major takeaway from this was it's roll your own security basically for OpenDLP. There were no anti-CSRF tokens or anything of that nature. The SSHFS stuff, the remote crawler, that was really just as good as having a really poor password on the login that's being used. So it's really kind of like BYOS. Bring your own security, right? So in this example, just using CSRF, I know it's hard to see, things are kind of pixelated, but using CSRF to basically delete a policy or a policy profile, so effectively makes it not work. Finally, from the first round, WebSense. So their policies at the time, presumably this is they are no longer doing this. But so we kind of talked about how policies work for most DLP products, and they have regular expressions, keywords, file attributes, the things that you want to look for and what you want to look in. In their case, for anything that was a regular expression on the Triton management server side, they used Python pickled objects written out to disk. Now, if you're familiar with at all, most of you probably know about Python pickle, serialization, marshalling library. Now, the problem with that is that Python pickle untrusted Python pickled objects when being deserialized can lead to code execution. So what they did was they would have all these things like English words, file types, first names in France, Italy, and each of those is a bunch of regular expressions on disk. They get encrypted, bundled, and then pushed to the agents and appliances. Here's an example of just deserializing one of them. You see some keywords and stuff. So what this led to was a scenario where, say, an admin already on the Triton server, and some organizations probably have different people doing different things, someone who manages the local server versus someone who actually manages all the DLP. They overwrite one of those pickled object files with their arbitrary code, their arbitrary pickled code, and this is our really bad proof of concept on the left, which I know it looks kind of dumb, but basically what it does is it opens up a reverse shell. When it got pushed down to, for example, the protector appliance, as you can see now I am root, because the endpoint, the classifier, policy engine classifier thing on the appliance runs as root. So it's the thing that's loading that pickled object. So overwrite pickle object on management server, gets pushed, get shell. Same goes for opening calc.exe on Windows. So alpha DLP, that was actually my favorite bug was the WebSense one. except for Dingus. It's Alpha DLP.
It's hard to remember when they have code names. So the good things about Alpha, there was no cross-site request forgery. Good job. There was no obvious cross-site flashing. Remember we talked about how the admin panel was in Flash? Well, at least they didn't have any cross-site flashing, which would be the Flash world equivalent of cross-site scripting. They also used Hibernate properly to communicate with the database, so no SQL injection. The bad, they did not have any authentication on the MySQL database, so meaning blank password. They did not hash any of they're like my margaritas, their hashes do not have salt, which is bad for if somebody does get a hold of those hashes, it would be a lot easier to reverse them. And it was also just extremely unstable, and we were using fairly robust hardware. So you see a combination of two problems here. One, it shouldn't be crashing in general, and two, it is giving you a lot of information about the internals of here with their verbose error message. So this is a problem with actually logging in, where you would log in and for some reason it would just 500. Just crashing very infrequently, not a very stable, and stability is what you want in a DLP product. Okay, in terms of the agent, we noticed a heavy use of marshalling between Java and Erlang. Maybe the potential for heap corruption. We didn't really have enough time to look into it, but there was some indications of that. The really bad takeaway, just the Java runtime environment that was packaged with it was really, really super old. And as you can see here, it was Java version 1.7.002, which is, how many years old is that? Very old. Too old. Especially when we talk about Java, which never has any security problems again. There was path manipulation in how the agent accessed the Erlang rules, so maybe a potential to point that agent to something malicious. And there's no assembly signing on .NET assemblies. This is something that is pretty common and not really the end of the world, but it does make it quite easy to modify an agent to make it do something else, which is what I did here. So you can see that on this side over here, the left-hand side, we have the original agent. We've blacked out the logo for anonymity reasons, and here we have modified it to be something way better, which is our new global APT configurator. So, why would you want to sign your code, or why would you want to sign your assemblies, your .NET? To prevent things like this from happening, to prevent somebody from creating a rogue agent that does bad things but looks like the real thing.
So Bravo DLP, this is Johnny Bravo. If you're not familiar with Johnny Bravo, it's a good cartoon. You should watch it. It's the best. So this was probably the most complex one, and most sophisticated, and fairly well thought out, actually. This is the one that used the MMC snap-in. But it's also the one that we spent a lot of time reversing. We kind of did that thing where you run out of time when you're doing research. That happens all the time. So basically spent too much time on it and got lazy and just moved on. So they use DCE RPC for communications between the agent and the management server, which is that's pretty good. There are a lot of benefits that could come with that. You get to build on all of Microsoft's whole communication stack, and you reap the benefits of that. So things like packet privacy. And actually doing, decent authentication. So packet privacy adds sets a bit and then adds encryption to DCE RPC comms. The only thing, though, free DCE did not support that for some reason. So all of the OS 10, again, this is pixelated, sorry. The OS 10 agent did not support packet privacy. So why is this bad? Well, there's an option in a lot of these called file shadowing. So if you, for instance, this is kind of that churn microcrawler example as well. When you are, you could have a policy that says, oh, I found a thing that violates, the DLP policy, send a copy up to the management server. Well, when it's being then sent in plain text to the management server from the OS 10 agent, that kind of defeats the purpose of of the DLP to begin with. So the copy of the file in question, if that option is enabled, from OS 10 would be sent in plain text. Cool. So Charlie DLP, no anti-CSRF tokens at all anywhere ever. So, and most of their operations in their web interface are done RESTfully. So here's an example: cross-site request forgery against an admin. If you hopefully can see this, you'll see like there's just a get to index.php/whatever/delete/id/2. Distinct lack of any kind of token that would prevent me from doing that. And Bob's your uncle, you delete a policy. So that's kind of unfortunate. Their management server also had the ability to arbitrarily, so when a new agent comes online, it will register over SOAP, over XML RPC. There's no authentication on that, so like I could just arbitrarily register new agents and run you out of all your licenses. But also, they don't sanitize any of the information being displayed. It's hard to see, again, I'm sorry. They don't actually sanitize any of the information being displayed to the admin when viewing new agents. So you could just add like C data in the SOAP envelope with like arbitrary JavaScript. So it's like pretty sweet, stored XSS. You can see I have my alert here, the requisite alert 1, and then it shows up when the admin goes to look at the agents. I could obviously do more, but that was easy. So finally, everyone's favorite, and
well, not everyone's favorite because it doesn't really exist.
It doesn't exist.
It doesn't.
Again, this is despite being redacted, this should be considered a completely hypothetical vendor that does not actually exist in the world. Mm-mm. Also, we had to hand draw some screenshots so we couldn't leave the original screenshots in there for this hypothetical vendor.
Yeah, because it doesn't exist, so there
aren't
real screenshots.
So Dingus, their network appliance, it has a support account, hypothetically, that actually reverse SSHs to an Eastern European-based SSH like prox, like a jump host, basically. As you can see here in the hand-drawn screenshot, this would have been an excerpt from that hypothetical script where it goes to support at whatever this hypothetical host name would be. And there's some scripts that it uses for various reasons. Hypothetically, they have the same DSA key. You heard me, DSA key, on all their virtual appliances out of the box, which means you have download another copy of their hypothetical virtual appliance. You have the same DSA key that they have, that next person has. It basically allows support to log in as root on the appliance from that jump host. It's invoked from the web interface. Here's another snippet where it then listens on port 20,000 TCP. So they also don't have CSRF tokens. So you could hypothetically CSRF an admin to invoke the SSH connection to an arbitrary host that you control with that same DSA key that you probably also have a copy of. And it's non-password protected DSA key. So that's bad, hypothetically. Here's an example of command injection, because it's like 1999. On this appliance, there's a file called injected does not exist. Using this burp example here, you'll note the semicolon that's here in the when setting the time zone. So if you CSRF an admin and add that semicolon, you can do whatever you want after that. So then, of course, now we have that file called injected is there, and it's owned by Apache. It's owned by Apache. That's dumb. Except that Dingus hypothetically also has a bunch of whitelisted no password sudoers entries for Apache. Not just anything, but like specific things like shutdown, ifconfig, move, chown, things that can be run as root by Apache without any password. So CSRF to, arbitrary package installation using RPM. And there's like no verify options, so you can just add your own kernel. So that's fun. Their hypothetical central console also had these were great, right? unauthenticated DB management scripts where you could just hit this one URL and actually like delete the entire database on the management server without authentication, or update it, whatever you want to do. The comms channel between the network appliance and the central management server was actually just hypothetically Postgres, plain text Postgres, with authentication using just a username and a database name. So you could also hit the central management server and do whatever you wanted to do.
Yeah, to give them credit, they did provide a lot of ways, lots of different flexibility for doing bad things.
They're not bugs, they're features. Yeah, that's a hand-drawn Wireshark screenshot.
Yeah, it's really good.
Screenshot. So yeah, that's their sync channel for communications.
So let's just breeze through this since we're kind of going over. So just a little bit talk about DLP bypasses. Evasion really is, okay, you're going to take away, how bad do you want this? You're going to take away all your people's cell phones. What are some other ways to sneak around DLP, evade detection? Figure out what file formats they don't use, which ones aren't supported, maybe protocols or doing weird things on the network. Sort of like heavily fragment and reorder your network traffic. Obfuscated, encrypted files, steganography sounds silly, but I've been able to get data not only, in a lab environment, sneak sensitive data out of my lab network by putting it in pictures of cats using steganography. And then also just think about what privilege do your users have? How many of them could just go and disable their endpoint agent? How badly, if somebody's really determined to get the stuff out of your network, again, DLP should really be thought of keeping honest people honest.
So finally, the takeaway here overall, other than the fun that we've had with bragging about hand-drawn screenshots, defenses add weakness. They every time you add something, even if it's a security product, you're running software, you're running a new piece of hardware, right with its own problems and its own attack surface. It's up to us, and this goes for those of us who also work at security companies. We should be better at this, but it's up to us to kind of keep vendors honest, right?
Right.
If Burp Scanner can find, and I'm not saying software is not complex. It's hard, right? Software development sucks. It takes a lot of time and planning, but little simple things like just security QA.
Yeah, Burp is cheap if you're not running it or if you're not using it or something like it when you are testing your stuff. Maybe shell out a couple $100 and catch the low-hanging fruits.
And then finally, this is sort of like one of those big picture security things. Just being aware of what you're actually defending against, who you're actually defending against, what actually are the threats against you. You like threat model your organization. Whoa. Because anyone who's inside or advanced and sophisticated enough is probably going to get those things out of the network and probably also own your DLP server in the process. So yeah, that's like the big picture takeaway. So thank you. We have time for questions. I think we have about 7 minutes or so.
Okay. Anyone? No? So that means the talk was either really, really good or really, really bad. All right. Well, then you get a free 6 minutes. Thank you.
Yeah, thank you. If you have any questions afterwards, just come find us.
We'll be
you can
wondering.
also find us on the internet, on the Twitter. I'm at Quine, she's at Aloria, and those are our email addresses if you would like to follow up. Thank you very much for coming, and enjoy the rest of the show.
Thank you.